Welcome to week 11, Introduction to C++. Here we are in the week 11 folder in the weekly learning, and we're just going to do a little recap from last week in this video, covering some of the concepts that we introduced, which was pointers and references from the PowerPoint last week, as well as this lovely little diagram that you'll recognize if you watched the video I sent out in the announcements here about pointers and dynamic memory allocation on YouTube. This is a really great 17-minute video. You can skip through it and get most of the concepts, but if you haven't watched it, it'll be a great reminder. So you might see me from time to time draw something like this out on the screen with a big square and then like little blocks of different memory allocation. So we'll go from the bottom up because I know the heap is kind of a new concept for people, and we talked a little bit about it last week and what dynamic memory is. So we'll start with the bottom one, the orange one, called code. And this is a segment of memory on our machine which is assigned to store the actual code, the source code, or the set of instructions that need to be executed. So you know how it translates code from source code to object code when it compiles it. Well, that's what this segment of memory is assigned to store. So this is not dynamic. It doesn't change. Once your code has been built by the compiler, it's a set amount of memory, okay? So it stays, what, if it's 3 megabytes, it stays 3 megabytes the whole time. So code doesn't change. It's just the instructions. The next section is the static or global, so the yellow block here. And this is where all our static and global variables are stored. So because they're outside of the main function, right? If we declare them at the very top of our program, then we can access them outside of all functions at any time throughout the entire lifetime of our application. And they'll have a full lifetime of the application. So they're accessible anywhere. This doesn't change either. So once our program's been compiled, it knows what the global variables are, it knows what the static variables are. It doesn't have to change or be dynamic because it can allocate 500 kilobytes of memory to those global variables, and then they're done. And they live while that application's running, and then it gets killed. The next section is the information here, because it has a little bit more that it does. So this stores all the information of function calls and local variables in our program. Local variables are declared inside functions, so you have your main function. Any variable that's declared in there is local to the main function. Functions like print, message, then any variables inside of that, like message or whatever, would be local variables. So all of those things and the functions themselves are stored in the stack, okay? Now, their lifetime is only the lifetime of that function. So when we've called print message, and it goes through all the different lines of logic in print message, which might be cout, printing the message, and then whatever, returning something, that local variable lives for that time only, and then it's gone, okay? So this amount of memory also does not grow while the application is running. It's not dynamic, it's static. So the stack does not grow. It's a fixed amount of size, and when we create arrays, when we create vectors, and the user adds elements, however many gigabytes of RAM you have on your machine, for memory, it can use that. But if you have a really big memory object like a vector or something, and the stack grows beyond whatever the reserved memory was in your RAM, then we run out of memory on the stack, and this is what's called a stack overflow. So kind of cool, the website where you go look up code snippets and stuff, Stack Overflow. It's the forums, the blogs online where people ask questions. That's what that's based off of, just kind of that name, Stack Overflow. So when you have a vector or an array that grows beyond the size of the stack, it overflows, and so the deallocation of memory on that stack happens by a set rule. So you might remember when we used vectors, we used dot push, I believe it is, to add an item to the vector. So when we add a function to our stack, or when we call a function in our program, it's actually pushed to the top of the stack, and then it runs, and then when it's finished, it's popped off the bottom. So that function only lives for the amount of time on the stack while it's running, and then it gets popped off because we don't need it anymore. So then we free up that memory. Okay, so all of this is stuff we've been using up until this point. It's automatic. It's the way C++ works and runs and segregates its memory allocation within the application. All right, now there's this new concept called the heap or the free store. And what's awesome about this and what's really powerful about this is it's dynamic. So it changes. We can allocate as much or as little as we need or want from the heap during the lifetime of our app. So it's for allocating really large chunks of memory, keeping an item in memory for the amount of time we want to, and then deleting it from our memory, which we talked about last week using that delete keyword. And we can totally control how much memory we want to use and how long we keep it, as long as we don't run out of memory on the system. So the heap obviously is way bigger. There's so much more memory available to allocate to our program. But obviously, if you only have like 500 gigabytes on your machine or whatever, and it's already used 400 gigabytes to store whatever programs you have, like Photoshop and all of that stuff, and you run out of available memory, then you'll also get a runtime error, your program will crash, and you have to be careful about that when you're using Heap. But for our purposes, we won't really ever have, to be aware of that you can stack and the heap. The heap is dynamic. So what this means, or what a good example of something like this would be, is say you had an array, okay, but you didn't know how many elements you wanted to put into the array. But for the specific use case of what we're doing, vectors doesn't make sense to dynamically add and like delete items from a vector. So we're using an array. But when you create an array, you have to tell the system how many elements are in it. Well, we can create an array on the heap, taking in a variable from the user, and it will create that dynamic element, that array on the heap. So we can actually create, dynamic memory on the heap, which is really cool. So hopefully that makes sense to you guys. That's kind of covering a little bit about what I'm talking about when I talk about the heap. We'll do another little video covering, I'll just split them up. So the next video section will be the review of the PowerPoint slides we covered last week up to slide 38. You'll see right here, I've attached it, and we're going to pick up from slide 38 from where we left off last week. So I'll end this video here.